we show a visible flow of Xorshift128 plus, which is a widely used pseudo-random number generator. We plot random points generated by Xorshift128 plus in the three-dimensional unit cube. Although those points should be uniform in the cube, they concentrate on particular planes. A key observation is that the exclusive OR is well approximated by arithmetic sum or subtraction with relatively high probability. We derive the equation of the planes which the outputs of Xorshift128 plus concentrate on, and estimate the distance of the points from the points. Xorshift128 plus is a family of pseudo-random number generators introduced by Sebastian Wigner in 2016, with many advantages. They passed the stringent test suite Big Crash in Test User 1. They are compact and very fast, and one of them is adopted as the standard pseudo-random number generator in JavaScript V8 engine. As a result, it is used in many major browsers such as Google Chrome, Firefox, etc. In MCM 2019, we pointed out a visible flow of the generator and showed that a simple Monte Carlo integration rejects the generator. At that time, we depended on a heuristic argument. Today, we give a detailed analysis. We show the equation of the planes on which the output concentrates, the probability of the concentration occurs, and the estimation of the distance from the planes. For a while, we give some pictures showing the flow of the generator. We consider a 3D plot of the random points in the unit cube generated by Xorshift128 plus. x1, x2, x3 are real numbers generated by Xorshift128 plus in 0-1 interval. We divide the sequence into triples in this way. To obtain random points in the unit cube, we plot 10,000 points. The result is this picture. The picture seems quite random. Next, we magnify the x-axis to 22 times as follows. If the first component is less than or equal to 22 minus 22, then we plot this point with x-axis magnified to 22 times. Otherwise, we skip plotting. This should be uniform in the unit cube. We repeat this until we obtain 10,000 points. The result is this picture. The points seem to concentrate on several planes. Wigner recommended 8 parameters of Xorshift128 plus in his paper. The previous page treated one of them. We showed that all 8 parameters have a similar defect. These pictures are for 2 other parameters with appropriate magnifications. From these experiments, we analyzed Xorshift128 plus and derived this result. The consecutive 3 outputs x, y, and z by Xorshift128 plus with parameter a, b, c, where a, b, and c are non-negative integers, tend to lie near on the 8 following planes. The left picture shows the union of the 8 planes in this cube. The right picture is the same planes, together with the random points generated by Xorshift128 plus. These pictures show that The generated points are very close to these planes with high probability. This page and the next describe the algorithm of Xorshift128 plus. We denote by W the set of W integers. W can be identified with the n-dimensional vector space over F2 by this correspondence. For two integers x and y, x plus y means the summation as integers, and XO plus Y means the bitwise exclusive OR. L and R are the matrices of size W defined in this way. Multiply L means 1 bit left shift, and multiply R means 1 bit right shift. We may repeat A times, and I is the identity matrix. Finds Xorshift128 plus generators. Xi denotes a 64-bit integer. The ith state is a pair Si, Si plus 1. The next state is given by this recursion. This is an F2 linear recursion. The output transformation is this, the arithmetic sum. This breaks F2 linearity of the output. The quality of Xorshift 128 plus depends on the choice of the parameter A, B, and C. And beginner showed that 8 parameters can pass big crash in test user 1. As a rough approximation, we replace plus with O plus in the output transformation. Then the new output O prime is F2 linear. Namely, O prime satisfies this linear recursion. Now, we focus only on the most significant n bits. For this, we introduce this notation. Then, the effect of right shift is annihilated as shown here. And the most significant n bits of O prime satisfies a very simple recursion. We heuristically assume that plus and O plus are similar and replace O plus by plus. Then that simple recursion becomes this arithmetic recursion. This is an example of classical multiple recursive generators, but the choice of the coefficients are not so good. Hence, we suspect that the original output might have similar correlation. Indeed, the experiments found the flaw. The heuristic seems too rude. We found a mathematical justification, which we shall explain. The outputs x, y, and z are obtained from these states. We show that the triple x, y, z tends to be near these three planes. In this talk, we treat only the first plane. The rest can be treated similarly, but we omit it. Recall this recursion, and z is the sum of si plus 2 and si plus 3. Here, this line is si plus 2 and the next line is si plus 3. As we have seen, the most significant n bits of these satisfy simpler recursion. Now, we introduce new notation, n-bit truncation un, and the truncation error delta u. The error is bounded, and truncation and O+ are compatible. We approximated the first term of z. It is approximated by an O+ sum of these three terms. Then the second term of z is approximated in a similar way. Thus, we have this relation. Now, we discuss how close is z to this value, with which probability. We make seemingly strong assumption that the both equation holds. Namely, O+ may be replaced with relevant plus or minus. Later, we shall show that this occurs with high probability. Note that the first term is just Si plus 1 truncated by n bits. This appeared in the previous slide. Thus, this equation was obtained in the previous slide. Since O+ disappears, we can change the order of terms. The first colored line is the main term, and the next line is an error term. Since this relation, the purple term is 228 times x, the red is x, and the blue is y. And hence, we obtained the desired equation with error term shown above. Since these terms are all non-negative and bounded, and there are 3 minus signs and 3 plus signs, the total error is bounded by this. We obtained this proposition. After normalization, this error, or this, is small, say for n equals 5. Next, we shall show that these equalities occur with high probability. If the initial shield is uniformly randomly chosen, then the probability that the assumption holds is 5 over 8 to n minus 1. Again, for n equals 5, this probability is rather high. We shall give a proof of proposition 2. We may assume that the pair Si plus 1 is independent. We name the 5 terms appeared in the assumption in this way. Then the first 4, being disjoint part of the pair Si plus 1, are independent and uniform, while T is determined by this. Thus, the proof of proposition 2 is reduced to proposition 3. This is an elementary problem of high school probability, just complicated. Not that complicated, we shall use this theorem. This theorem says that the exclusive OR of 3 terms coincide with their linear combination with coefficients in plus minus 1 often. The condition can be stated bitwise. In this talk, we use the case P is minus 1, Q and R are 1. This is the case 2. Thus, for each bit, among 8 possible patterns, 6 patterns satisfy the condition. This occurs with probability 6 over 8 to n. If we take modulo 2 to n, the condition on the most significant bit is dropped. Here is a proof of theorem, but we omit it in this talk. Using theorem, we obtain the probability that our assumption holds. The condition is that this holds and that this holds. The relation 4 is equivalent to this. Thus, the probability the relation 4 holds is 6 over 8 to n minus 1. Next, we compute the conditional probability under the condition 4. Our aim is that the probability this occurs. Because of the condition, we have 12 cases equally probable. T is determined by U, V, and W. We list 12 cases for the value of W, Si, Ti. Then 10 of 12 satisfies this condition. Thus, the conditional probability is 10 over 12 to n minus 1, and the probability that the two conditions holds is 5 over 8 to n minus 1. We omit the details, but other planes can be analyzed similarly. The results are here. In this talk, we show that 3D plots by Xorshift128 Plus concentrate on planes and give a mathematical analysis. Xorshift128 Plus are designed by choosing parameters to pass big crash. However, we can reveal a visible flow. Of course, statistical tests on pseudorandom number generators are very important, but it seems risky to select parameters or design of PRNGs by means of the statistical tests. Thank you for your attention.